Hello, everyone. This is Mrs. Leong, and I will be going over lesson 1.2, Properties of Real Numbers for Honors Algebra 2 today. All right, so for this lesson, we're going to cover a bunch of terms, specifically categories for numbers that we are going to be using. And we're also going to be talking about some properties. Those should hopefully look familiar from geometry. All right, so reviewing some of that and specifically talking about additive inverses and multiplicative inverses. All right, so that's pretty much what we're going to be covering for this lesson today. All right, so let's get into it. Here we go. If you're following along with your notes, we're going to be going ahead and drawing a big box around all of this. And basically, any number that you can think of is a real number. We're just going to use R as our little shortcut there. All right, so real numbers are basically any numbers you can think of, positive, negative, zero, decimal, fractions, radicals, any of it. It's all under real numbers. All right. And within the umbrella of real numbers, there's two subcategories, and those are the irrational numbers and the rational numbers. I'm going to go down here. All right, so rational numbers versus irrational numbers. And those two don't intersect, all right? So all real numbers can be categorized under either a rational number or an irrational number. All right, so let me tell you what a rational number is. A rational number is any number that can be represented in a fraction form, all right, like m over n, where m and n are integers. So for example, like 1/2 is a rational number, all right? -10/3 would be considered a rational number. Even like 0.7, all right, is a rational number because I can write it as 7/10. So it doesn't have to be in fraction form to be a rational number. As long as it can be written as a fraction, it's considered a rational number. So like 0 is also a rational number because I could write 0 as 0/1. Okay, so that would be a fraction. Yeah, so anything that can be written as a fraction is a rational number. All right, and irrational numbers are basically numbers that cannot. All right, so numbers that can't be written as a fraction will be an irrational number. And typically these are like non-terminating, meaning it doesn't stop, and non-repeating decimal. So if it's a decimal that just keeps on going forever and there's no pattern, there's no repeating, that is an irrational number. You can't write it as a fraction. So one of the most famous ones that you probably know is pi. So pi is an irrational number because the decimal is 3.14, 159, dot, 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 dot. It just keeps on going. All right, so that's an example. Rad2 is another example. All right, if you type that into your calculator, you'll get a bunch of decimals that don't repeat. Rad3, Rad4 would not. All right, Rad4 is a rational number because that could be simplified to 2, which could be written as a fraction. So this would be a rational number. Okay. All right, so again, under the umbrella of real numbers, the overarching umbrella, underneath that, there's two categories, rational and irrational. And under the rational, you can also have integers, whole numbers, and natural numbers. All right. And if it's a rational number, it could be considered an integer if it's one of these numbers over here, like -3, -2, -1, 0, 1, 2, 3. How I like to remember that is basically anything that you usually would tick off on a number line is an integer, right? In most number lines you see, only the integers are shown in those tick marks. So that's how I remember it. Whole numbers is under integers, so you guys can see this kind of diagram here. So you got our rational numbers, and within that we have our integers, and within that we have whole numbers. And whole numbers are basically positive integers, so only the positives, plus 0. All right. So positive integers and 0. And kind of the cheesy, but kind of, I think, helpful way for me to remember this is whole numbers has a whole. All right. Hopefully that'll help somebody. Okay. And then under that, there is our last one, which is natural numbers. All right. So natural numbers right there. And natural numbers are basically exactly like whole numbers, just without the 0. All right. So 1, 2, 3, 4. So positive integers, basically. All right. So positive integers. How I like to remember this is natural numbers are the numbers we naturally count with, right? When you use your fingers to count, we naturally will count 1, 2, 3, 4, 5, etc. All right. So those are all the categories for our real numbers here. Okay, let's get into some examples so you guys can test yourselves and see if you can identify the number sets to which each number belongs. All right, so name the set of numbers to which each number belongs. And I'm going to use this shortcut key here instead of writing out all of those words. All right, so feel free to use this, or if you're not sure, feel free to write out the actual words. Totally up to you. All right, let's try it. Here we go. Number 1, I have rad 16. Okay, so rad 16 I know is equal to 4. Okay. So the first thing I know is, well, it's definitely a real number. All right, most numbers are real numbers, so we're just going to start there with R. Okay, then I'm going to go under that, and I'm going to think rational or irrational. All right, it's either one or the other. Okay, 4 I can write as a fraction, right? 4 over 1. So I'm going to call that a rational number. Okay. I know it's not irrational because I already discovered that it's rational. So under that, I'm going to ask myself if it's an integer. Integer. Yeah, I would mark 4 on a number line. So I'm going to say integer. And under that, is it a whole number? Yeah, it's a positive integer. All right, so it's definitely a whole number and also a natural number. Okay, and that is my final answer. Those are all the sets of numbers to which it belongs to. Okay, let me show you another one. Let's see. All right, number 2. All right, number 2, same thing. Negative 185, definitely a real number. Rational or irrational, I can write that as a fraction if I put it over 1. All right, so I'm going to mark that Q for rational. Is it an integer? Yeah, it's definitely an integer. I can mark that on the number line. And is it a whole number? Ooh, I'm going to say no on that one. A whole number is only 0 and the positive. So since that's negative, it's not a whole number. So I'm just going to stop right there. Okay. I'm not even going to ask about the natural numbers because if it's not a whole number, it's definitely not a natural number. Okay, let me do one more and then I'll have you guys just practice a little bit with 4 and 5. Okay, so number 3, rad 20. All right, rad 20 doesn't simplify to like a nice clean number. It's going to have that, repeating or non-repeating, non-terminating decimal. So I do know that it's real, but it is not going to be rational. I cannot write that as a fraction. Some people might be like, oh, but I can put, rad 20 over 1, it's a fraction. But I'm going to say no. M and N, if you're going to write as a fraction, have to be integers. All right, and rad 20 is not an integer. So this is not a rational number. Therefore, it is an irrational number. And there you go. Okay, so what I want you to do is go ahead and just pause the video right now. Try number 4 and 5 on your own. And once you're done, go ahead and unpause, and then you can see if you got the right answer. All right, let's go ahead and give 4 and 5 a shot. All right, once you're done with 4 and 5, you can go ahead and see what you got here. And the answer I got for number 4 was that it is a real number. It is rational. It is not an integer. I would not mark that on my number line. So I'm going to stop right there. Okay, and then number 5, this is going to be real. And now, because it's a decimal that keeps on going, I might be tempted to think it is irrational, but it actually has a pattern. It repeats. It's 0.45454545. So I can actually write that as a fraction. So that would be a rational number. Okay. Definitely not an integer. I wouldn't mark that on a typical number line. So I would stop right there. And by the way, if you're wondering how that could be a fraction, this would be 45 over 99, which I would simplify to be 5 over 11, in case you're curious. All right, so that finishes up our categories of numbers here, all right, or number sets. Okay, let's go ahead and move on to property of real numbers. I'm sure you guys have all seen these before and remember proofs back in geometry. Ooh, I don't think we're gonna be doing proofs, so you don't have to worry about that if you're like, don't wanna do that again. I will say this, closure property, don't worry so much about this one. This is almost like a given. People don't even really say it anymore. Basically, anytime you do an operation within the real number system, you're going to kind of stay in the real number system. So don't worry about that. It's not going to be tested. Focusing on these other guys: commutative property, associative, identity, inverse, and distributive. All right, be able to recognize when it's being used. Okay, so here we go. Number 6. All right. So, I didn't go over it just because I'm assuming you guys know this from geometry, but if you need to take a time to kind of like review over these, go ahead and pause the video and just kind of look over just to refresh your memory on what's commutative, right? What's associative, identity, and inverse. All right, same for addition and multiplication. All right. And once you're ready, unpause, and then we can get into these examples. Okay, name the property illustrated by each equation. All right, so here what I see is 5 plus 7, in parentheses, plus 8, became 8 plus 5 plus 7. So what I see is that this and this have switched places. All right, so looking at that, I'm going to say commutative. All right, commutative property of addition, but just go ahead and write commutative, and that is it. All right, because this is A plus B. Let me give myself some room here. Because it went from A plus B to be B plus A. And that is our commutative property right here. Silly kind of way that I remember this. I actually have terrible memory. You can ask anyone that knows me. So I have to think of ways to help myself remember things. Commutative property, I think of like a commute, somebody driving to work. Things move around, all right? So when I see this, the order changed, right? Order changed. They commuted. They moved around. All right, here's my little car drawing to kind of help you remember that. Okay. So order change, order, the terms moved. Maybe that's another way to think of it. The terms moved. All right. So it's going to be commutative. But if you look at number 7, all right, number 7, we have 3 times 4x, and this one is 3 times 4 times x. So if you notice, the terms actually didn't move. 3, 4x, 3, 4x, right? Nothing moved. So this is not commutative. But the only difference is that the parentheses, all right, went around 3 and 4 instead. So you would do 3 and 4 first. All right, so this is associative. All right, associative property of multiplication. You could just write associative, and that's fine. All right, because if you look up here, notice ABC, ABC, right? None of those terms moved. The only thing that changed was the parentheses, all right, where the parentheses went. So that is associative. Okay. Usually people get, commutative and associative property kind of mixed up. So hopefully that helps you guys distinguish between the two. All right, you'll practice more of these properties on your homework, but I do want to go into the, sorry, I'm moving this up and down. Let me go into the identity and inverse property a little bit differently. All right, instead of having you identify, I want you to actually find the additive inverse and the multiplicative inverse for each number. All right, so for this number and this number. So the additive inverse, we know it's the inverse if the two numbers add up to 0, right? And really, when you have a number, as long as you have the opposite sign being added together, that's what makes it 0, right? 2 plus -2, 100 plus -100, -50 plus +50. So as long as the number, I guess, is the same, it's just opposite signs, that is the additive inverse. So I would say it's pretty straightforward for the additive inverse. Let's say additive inverse is going to be positive 1 3/4. Okay, so opposite sign. For number 9, I'll just jump over while we're talking about the additive inverse. This will just be negative 1.25. All right, so pretty straightforward, additive inverse, opposite sign. Okay, multiplicative inverse. This is going to be the reciprocal. All right. So to find the multiplicative inverse for a number, you multiply by the reciprocal right over here. Like a would be multiplied by 1 over a to get 1. That's what you're aiming for. All right. So two numbers are multiplicative inverses if they multiply to equal to 1. All right, so then we want to get the reciprocal of this guy. Okay, so the multiplicative inverse. It's a little bit trickier to see the reciprocal when it's in a mixed fraction like this. So I'm going to go ahead and convert this to an improper fraction. If you don't remember how to do that, you just do 4 times -1 plus 3. Okay, and that's how I got my -7. And then I can do the reciprocal of that by flipping it around. So -4 over 7. And that's my multiplicative inverse. All right, number 9. For this one, to find the reciprocal, I'll go ahead and write this in fraction form and then write that into an improper fraction. All right, and now it'll be easy to do the reciprocal. So 4 over 5 would be the inverse. I would convert that to a decimal. I like to kind of keep the same form, I guess, of the number. Like if like the original problem is a decimal, I like to leave my answer in that same form. Okay, so I'm going to leave that as 0.8. And that's your multiplicative inverse. All right. And we got one last problem here to finish off our properties. I think we hit on most of them, and now we just are talking about distributive, all right, to help simplify. All right, so to wrap up this lesson, let's go ahead and let me just show you distributive property just to refresh your memory. I'm sure a lot of you guys know how to do this already. Simplify, that just means, try to get rid of all the parentheses, combine like terms, all that jazz. All right, so distributive property, 2 times 5n gets me 10m. 2 times n gets me 2n. Distribute that +3, we get +6m minus 12n. All right, let's go ahead and combine like terms. I have an m and an m here. Adding those up, I get 16m. I have a +2n and a -12n, which gets me -10n. All right, and that's as simplified as I can go. All right, and that is lesson 1.2.